we have looked at sample surveys, and those are a good tool for describing a population. Now we're going to look at experiments, and experiments are the preferred method for examining how one variable affects another. In an experiment, we can control an explanatory variable and see what effect it has on a response variable. First, let's take a look at some definitions. An experiment deliberately imposes a treatment on individuals to observe their responses. The purpose of an experiment is to study whether the treatment causes a change in the response. Some experiments have a control group, and a control group is a group of individuals in the experiment who do not receive the treatment. And this is good to have because it gives experimenters something to compare the treatment group with. An experiment with no control group is called an uncontrolled experiment, and these are generally considered not as good as experiments with control groups. A randomized comparative experiment randomly assigns individuals to either the control group or the treatment group. So we'll have some number of subjects for the experiment and randomly assign them to either the group that gets the treatment or to a control group. Let's look at an example. A college offers a review course to prepare students for the GMAT, an admission test required by graduate business schools. This year it offered only an online version of the course. The average GMAT score of students in the online class was 10% higher than the average of previous students who took the classroom version of the course. So in this experiment, we had a group of subjects who are the students. They were exposed to a treatment, the online course, and the outcome, their test scores, was observed. In this case, we have no control group, so this is an uncontrolled experiment. All of the students were in the online course. We can represent this experiment in this way. So we have online course and then an arrow and then observed GMAT scores. So in general, to represent an experiment like this, you would have the treatment and then an arrow and then observe the response. One issue that can come up in experiments is called confounding. Variables are said to be confounded when their effects on the outcome cannot be distinguished from each other. So in our example of the GMAT review course, it turns out that students in the online course were in fact very different from students in previous classroom courses. The average age of students was older, and students were more likely to be employed. So in this case, age and background could be a confounding variable. The fact that the students were older and employed may have made them more likely to get higher scores regardless of whether their course was online or whether they took the in-classroom course. And that's a difference in the individuals that we didn't consider in the experiment. For example 2, we'll look at a randomized comparative experiment and try and look at the same thing. So the college now decides to compare students in a classroom course to those in an online course. So in this case, we're going to have a control group of students in the classroom course. From a group of 50 students, 25 of them are randomly assigned to the online course. So to represent this experiment, it's going to be a little bit more complicated, but we'll draw a diagram for this. So to start out with, we have 50 students available. The next step is to randomly assign students to two groups. 25 of the students will receive the first treatment, the online instruction, and 25 of the students will receive the second treatment, or the control group, the classroom instruction. And then after the courses is over, we're going to compare the groups on the common outcome measure, which is their test scores. Keep in mind that the performance of the two groups would differ even if the treatments were identical, because the individuals in the groups are different. So, for any two groups of students, there's going to be a difference in their average test score. And we want to think about how much of a difference is significant. And when doing an experiment, we want to show that a treatment's effect is statistically significant. So only differences that are larger than would plausibly occur just by chance show the effects of the treatment. An observed effect that is so large that it would rarely occur by chance is called statistically significant. So in our example of the students in the two different courses, if the scores of the online students on the test were on average 3% higher than the scores of the students in the classroom, then that might not be statistically significant. There might be just chance that they were a little bit higher. But if there was a larger difference, say 12% in the test scores, then that might be statistically significant and show that the type of instruction had an effect on test scores. So for this section, things you should know. You should know what makes an experiment different from a survey, and that is that we control the explanatory variable and see how it affects a response variable. Understand the difference between an uncontrolled experiment and a randomized comparative experiment. So the uncontrolled experiment had no control group. That was the case when we just had the online class and we didn't have anything to compare them to. A randomized comparative experiment takes the subject and divides them randomly into two groups that receive different treatments, and then we compare the outcome at the end of the experiment. You should know what a confounding variable is, and this is something that may not be accounted for in the experiment that could affect the results. And also understand what it means for an effect to be statistically significant. So that is large enough that it would rarely occur by chance.